Hello, my name is Pashev, and today I'll be presenting our work titled The Web Foreign Language Assessment with Integrated Speech-to-Speech Translation and Multimodal Learning Analytics, which is authored by me and Silvia Gaftandzhieva from University of Plovdiv, Paisii Hilendarski. We're going through the main sections of our paper: introduction, system overview, architecture, test generation, evaluation, results and impact, and conclusion. By converging of different technologies which are typically used for different things like NLP, speech-to-speech translation, and Bloom's taxonomy, we aim to transform foreign language assessment. And by using advanced speech recognition, we aim for real-time evaluation of learner responses for intelligent adaptive assessment systems. We also introduce a novel formal model that leverages these technologies to create an automated, cognitively informed, and multilingual assessment tool. The system supports 60 languages and integrates spoken and written assessment. Moreover, we incorporate Bloom's taxonomy, and thus we ensure that assessments are not only language focused but also stimulate higher order thinking skills, which particularly means that it can be used for multi domain purposes. We made a research and we saw a lack of formal integration. As existing systems often lack formal integration between cognitive frameworks and multilingual speech technologies. So this gap results in assessments that either focus solely on language proficiency or fail to leverage the full potential of AI for adaptive and scalable evaluation. So we saw that there is a significant need for a unified model that combines pedagogical soundness with real-time speech processing. This model should support scalable adaptive language assessment across multiple languages and cognitive levels, ensuring both linguistic and cognitive validity. We've got a seven tuple system formal model, which includes L, supported languages, C, Bloom's cognitive levels, T, test unit templates, A, AI processing modules, F, set of assessment functions, M, set of multimodal measurement metrics, and V, cognitive mapping function. The system supports over 60 languages, ensuring broad linguistic coverage and adaptability. The six Bloom's cognitive levels are integrated into the system, allowing for assessments that target different levels of cognitive complexity. This ensures that learners are evaluated not only on language proficiency, but also on their ability to think critically. The system incorporates multimodal learning analytics combining acoustic, linguistic, temporal, and cognitive signals to provide comprehensive evaluation of learners' performance. What is the core component is the cognitive mapping function phi that assigns each test unit template and language pair to an appropriate Bloom level, ensuring that assessments are aligned with educational objectives. We'll be speaking about educational objectives more in the next slides. We've got AI pipeline composition P that integrates automatic speech recognition, machine translation, and text to speech synthesis. This seamless pipeline enables real-time speech-to-speech translation, supporting multilingual assessment with low latency. Moreover, we do semantic analysis extracts, meaning representation for learner responses, providing deeper understanding of their language proficiency and cognitive abilities. We try to do real-time processing with minimal end-to-end latency, ensuring smooth and efficient assessment experience. We've got five core modules in our system architecture, which include cognitive assessment engine, speech processing pipeline, multimodal analytics engine, adaptive learning controller, and bias direct detection. Each module implements specific aspects. First, we start with the Whisper ASR, which provides robust speech recognition capabilities. This accurately transcribes learner responses, forming the foundation for subsequent processing steps. Feature extraction engine extracts acoustic, linguistic, temporal, and cognitive features from learner's responses. Weighted aggregation. As these features are normalized and combined through weighted aggregation, they produce a comprehensive assessment score. This process ensures that all aspects of learner performance are considered. We get test generator that aligns to Bloom level, it aligns to linguistic and cultural appropriateness, and it has specific evaluation criteria. Each template includes specific evaluation criteria that define success metrics. These criteria ensure that assessments are accurately scored and provide meaningful feedback to learners. Moreover, we have this adaptation algorithm which adjusts templates across language pairs using the complexity function. This algorithm ensures cognitive level consistency while accounting for linguistic differences and maintains pedagogical effectiveness. After having the feature normalization and weighted aggregation, we generate automatically interpretable feedback. This feedback enhances the learning experience. So the feedback can be and is something like you need to work more on Bloom level number, for example, 5, to learn concepts A, B, C, D, etc. In test type speaking or listening. And so the system will try to generate more and more test units that it detects your weakness is most crucial there. That's why we also talk about adaptive learning systems. Because we already know which test units the learner failed, which type of test units the learner failed, uh, which cognitive levels of Bloom taxonomy were these test units of, what type of concepts these test units were about, what language task the test unit tried to evaluate, for example, listening, speaking, etc. And we can generate more and more test units and, for example, learning contents about where the learner failed most. And that's why we made this adaptive function alpha, which adjusts task difficulty based on learner performance history and profile. This function ensures that assessments are tailored to individual needs, promoting effective learning. We got also learning velocity and master indicators to inform real-time cognitive level progression. And to get all this running smoothly, we did a multi-phase evaluation plan. First, we need to validate the theoretical robustness of our 7-tuple model. Then we need to do some component testing. We've already done that, but we'll go on with doing this. Then we need system integration testing. This phase ensures that all components work together seamlessly. And then educational effectiveness studies. We must say that we are in the beginning of this big project, I would say, but we already have some good results. We've got 70% complete the core pipeline, and we have 85% expert agreement on cognitive mapping and 94% ASR accuracy for high resource languages. So these metrics highlight the system's accuracy. But I repeat, we have many things to develop and do and to be presented in future works. These are our theoretical contributions. We got this formal integration with the Bloom taxonomy. We also have cognitive complexity function quantifiers. We've got multimodal assessment theory, which integrates acoustic, linguistic, temporal, and cognitive measurements. And in practice, that means we somehow tried and maybe achieved inclusive assessment by promoting educational equity, by ensuring accessibility and cultural sensitivity, etc., etc. We did create a unified framework with cognitive mapping and adaptive progression. But we need to do so much more to get a really good product. We need empirical validation, we need cross domain applications. So, this project will scale, and I hope it will scale with more and more people in team to do the validation, to do cross domain applications. And as I say cross domain applications, I also mean that the real power of Bloom's taxonomy is in actually learning some stuff in various domains rather than just learning language. But we also use specific concepts in language learning theory to integrate them with the Bloom's taxonomy to make it useful even in the general use case of just learning language. But as I say, cross domain applications, learning in a foreign language will be, I think, the best part of application of this system. So I'd like to thank you for listening to this presentation, and I hope it was somehow interesting and useful. for even your future research. And if you have any questions, please do not hesitate to ask me.